right, our next presenter is Megan McDonald, who's a principal engineer with the New Mexico Abandoned Mine Land Program. She has a technical background in mining and civil engineering and is passionate about improving the lives of New Mexicans living near coal, metal, and uranium mine lands. All.
Can everyone hear me okay? All right, thank you. Well, thanks for having me here today. I'm happy to present on my project from New Mexico. This project is a sinkhole and a leach field in Allison, New Mexico. My name is Megan McDonald, and I've been with the AML program for about 7 years now. So this project is located on the western outskirts of Gallup, New Mexico, which is on the western side of the state. And it's famous for being along the historic Route 66, along for some very famous geology in the area, pretty similar actually to some of the stuff we see around here. So historic coal mining community. There were many, many coal mines in Gallup in the late 1800s, early 1900s. And in particular, we're looking at the community of Allison, which is just about a mile west of the town site proper. And you can see the town right through here. Our project area is in red, and then the subsidence area is right here. So mining in Allison was conducted from 1893 to about 1939 or 1940. This corresponded with their mining peaks happened during the First World War, increasing production, and then by the time of the Great Depression, the mine had shut down by 1939. But it was a room and pillar underground coal mine. It had a series of shafts and declined adits, 3 million tons of coal mined between these time periods from 2 seams located at the mine. This is a picture that we found from the Library of Congress of the Allison mine. It shows the town site, which is quite close to the mine itself. This picture split up, so it was really like a big panorama going across. Some of the mining features, like the rail bed is still there. You can see where the rail line was, but none of the infrastructure from the mine is there anymore. A lot of the town site, there's a few of the original houses that are still preserved. And this helped us to provide a reference point for what we were looking for with our subsidence. So this is a historic mine map from 1932, a little bit fuzzy, but it's overlain or underlain between the town map. But the mine itself covers a whole section area, like township and range section. This shows a variety of features that are located at the project site. Lots of shafts, lots of portals. All of those were closed in the 70s before the New Mexico AML program came along. So not a lot to reference while we were there, but we did know that because of the depth of the coal seams and because of the mining method that it was prone to subsidence. We'd worked on this area in the 1980s for some houses that were experiencing subsidence, and all was quiet for many a decade. Until 2015, when a sinkhole opened up in a resident's backyard. This was probably just about maybe 60 feet or so from the resident's mobile home. And it was in the monsoon season in New Mexico. Just like here, we get a lot of very heavy rains in the summer. And one morning, he just came out of his house, and there was a huge sinkhole that had opened up in his backyard. So this one, when it first opened up, was 20 to 30 feet deep. 20 to 30 feet in diameter and only about 15 feet deep. But you could see like a piping hole going further down into it. And it was right behind the backyard. There is a historic drainage channel that crosses right over this sinkhole path. So right after that monsoon rain happened and that channel was flowing is when this sinkhole opened and all the water just dumped into it. So not only with the sinkhole feature that opened, there were a lot of tension cracks that opened up concentric to the sinkhole. Some of them were just a few inches wide, but others were nearly 2 feet wide. This resident is standing in his backyard and he stuck a 10-foot long section of PVC pipe in there. And he stopped when he just knew he was going to lose his piece of pipe. So these cracks went down quite a ways. And based on this, the AMO program knew that we had an emergency situation on our hands. So we went ahead and pursued an emergency project with OSM. Even though we don't have a full-time emergency projects, once in a while we get something like this popping up. So our first step was to assess the underground characteristics of this site to determine if there was a safe way for us to get equipment to the edge of this sinkhole. So we worked with a local consulting firm, geotechnical consulting firm, to do some exploratory drilling, take some samples, and determine what we were working with here. This subsurface profile was developed by Alan Kuhn Associates. You can see the sinkhole surface expression right here, which is actually just a small part of what's going on. There are tension cracks that go through into about 80 to 100 feet into the first mined out area. But what was special about this sinkhole is that all the way down to the coal mine area, it was nothing but loose alluvium, so complete soil. We found out that the town site actually sits within something called an old paleo valley, where there's bedrock all around, but sometime in the long past, the area was eroded out and then filled with over 100 feet of sediment. So the miners, when they were mining along in their first seam, it looks like they punched a drift into this alluvial area, and it made a point of weakness where future subsidence could occur. So we knew that the problem area was in the first seam that was about 80 to 100 feet below ground surface. There's another coal seam at about 150 feet, but it was not mined in this particular area that we could see of the sinkhole. So our phase one emergency construction was to just take care of this big sinkhole in the neighbor's backyard so that it was safe for him to be out there. We worked with a local construction firm who brought out a long arm excavator, was able to excavate all that loose, wet alluvium. We came through no groundwater encountered, but there was just like perched lenses of water that would pour out as they were excavating. But they're very close to the edge of the sinkhole in this picture. They did push the boundary a little bit, but they were able to use that long arm to at least keep a distance when they could. And we backfilled with a rubblized concrete to give like a good solid foundation area there for this backfill, in the hopes that it would hold and we could work on a non-emergency project. But soon after, I'd say about like a year after that first sinkhole was taken care of, we had another smaller sinkhole open up right next to the first one. This one wasn't as deep. It was a little further out into a neighbor's field. And it did give us some pause because we're wondering, what's going on here. But we were able to fence it off. We're trying to avoid another emergency project. And we're putting together the non-emergency project as this is going on. But then as we're continuing our periodic monitoring, we found that the tension cracks kept growing. So you can see this is a drone photo that the neighbor took. And you can see this tension crack here. And you can see this pattern where they're actually all interconnected surrounding this subsidence area. This is that drainage channel running north-south through the property, and these are the backyards of the residences. So this gave us definitely some pause and wondering where this was going. What finally tipped it over into another phase of an emergency was when a neighbor saw a mama cow standing around a little hole, and the mama cow was just mooing and mooing. And then the neighbor peeked into the hole, and there was a calf that had punched through the ground into this hole, and there was a subsurface space, and the calf was just stuck in this hole. And so the neighbor, the calf was okay. The neighbor had a backhoe, thank goodness, and was able to very carefully excavate and get that baby cow out and get it reunited to its mom. But we realized if a calf had fallen through the ground like that, this was a huge emergency issue for any people that might be walking around out there. So we pursued another phase of an emergency project out at Allison. It involved working with Golder Associates, our engineering consultant, to develop a geotechnical exploration plan so we could further define that subsidence area and see what we needed to do for a more permanent solution. The more permanent solution was to drill and grout. We knew we needed to construct a bulkhead to seal off that problem drift, and we knew we needed to stiffen up the soils in that paleo valley, all in that area where the tension cracks were, in order to make it safe for the residents. So this is a figure showing a cross-section of the subsidence area here. This is where we backfilled for the first emergency. Our target was to drill down from the surface and to construct a bulkhead in the #1 coal seam where this drift just punched into the alluvium in this paleo valley here, and then drill all around where the tension cracks were and do compaction grouting to stiffen up those soils and create firmer ground. We had a pretty traditional grout mix design for the bulkhead and for the compaction grouting, nothing too fancy. We had like a slump requirement, a water to cement ratio requirement. We had no strength requirement, but the grout was actually pretty strong. We did take tests for it. And the target was to do lifts every 3 feet. So drill down to depth, inject grout and pressurize, pull up 3 feet, and repeat this process until we were finished with that borehole. And we had different cutoff criteria for the bulkhead versus the compaction grouting. We wanted to make sure we didn't heave the ground and cause too much ground disturbance. And then also we weren't just pumping grout into the mine workings. So our prime construction contractor was Nicholson Construction. They're based out of Denver. I'm sure a lot of people in Subsidence have worked with them before. They were a very good crew out there for us. Most of their crew came from Wyoming, where they had experience with the Wyoming AML on a lot of Subsidence projects. So they did a really good job. They had some good experience that they applied to our project. So their first step was to drill the bulkhead and to seal off that area. So we had 27 boreholes that Nicholson drilled into this area and did the injection of the grout. And they had one drill rig that would drill down and hit the target depth and open it up. Then the second drill would come and apply the grout that way. So it was traditional drilling method. They had 3.5-inch diameter hollow drill rods. They used a variety of drill bits. They had like a cutting shoe with carbide tip teeth. They moved to a tricone bit. It was a challenge to drill through all of this clayey alluvial soils because it was a very, it was like almost like a fat clay, and it would really gum up the drill bits and it would make it really hard to pull out the casing. But with their experience and trying this and that drill bit, they were able to get those boreholes installed and grouted. A trickier problem was deciding whether we had actually hit the drift or not, because the mine map, if you measured it out, it showed the drift was about 16 feet wide. But when we drilled, it was nowhere near that. It was really only about 8 feet wide. So what we did was we used Golder had installed some monitoring boreholes in a known hit in that drift. And when the Nicholson rig actually hit the drift, all the pressure from their drilling and would shoot water and mud and coal out of these monitoring boreholes. So it was like Old Faithful, and everybody was excited that we knew we'd hit the drift, and they knew that was where they could grout. So when the bulkhead was finished, we moved on to compaction grouting. These were on 12-foot centers. And they moved along through the blue area. That was like our high risk zone. And then moving on to the pink area and to the yellow area, and just moving in a grid and compacting those soils and stiffening them up. While we were doing the compaction grouting, we ran into a challenge where the drillers started to notice foaming water that was really odoriferous coming out of the ground and out of their boreholes. And there was a suspicious puddle in a resident's backyard that never really seemed to evaporate, even though we didn't have any rain or snow. And so we knew that at that point we were dealing with something involving a septic system. So this is a picture of the septic system with our neighborhood dogs checking it out for us. And it turns out this, we're used to a septic system where you have a tank and a leach field, but this system actually dates back to mining times, and it's actually more appropriately described as like a cesspool. All it was a rectangular box made out of timbers, and the property owner had never pumped it. And all the time that they lived there, they never had to pump a cesspool. So we had a theory over time that the waste was actually draining through these ground cracks that were probably just slowly developing over time and down into the mine workings. And there are many septic systems in the area that are like that. So we had to involve the New Mexico Environment Department on this issue in order for us to keep going on the project. We helped the resident clear out the backyard. There was a lot of stuff in there. Here's the sinkhole. The septic system is right here, and you can see how all of the tension cracks and everything impacted that. So even though that system wasn't designed well, it was impacted by mining. So we were able to use AML money on this project. So we installed a state-of-the-art, latest and greatest septic system for this resident, complete with, the standard tank, the leach field that was properly installed. There were neighbors had drinking water wells that were close to this, so we really had to work with the property to not get within that zone. Allison has a long history of contaminated water, and that'll be another presentation. A little too much to go into that. But anyway, once the septic system was installed, this was a big benefit for the resident, just to improve the family's quality of life. We were able to continue with compaction grouting and finish up the area. We made sure not to put that grout too close to underneath the septic system so that it could still properly perform and it could drain. We worked to reestablish the drainage channel through that area and finished up with seeding and mulching. Final project test quantities on there. We ended up doing 27 holes for the bulkhead, about 100 holes for the compaction grouting, and we spent about $2.5 million on this project. So we're working into the future. This emergency is over now, but we know now that in Allison and in the Gallup area in general, it's definitely prone to subsidence. And so we worked with Golder Associates to develop a sinkhole risk rating to try to define areas that we should target for our future projects. Using that risk rating, Golder has developed a map of the town site showing some high, medium, and low risk areas. The high-risk areas are shown in red, to medium is orange, and that's where we're targeting our next efforts, where we're focusing on geotechnical investigations and trying to put together some subsidence projects to prevent something like this happening in the future. We're also working with WSP, another consultant, to reestablish the drainage channel through the town. Previously, it's really just a soil channel that the residents have just kind of dug out periodically. So we wanted to install something that will help convey the water, the surface water, well away from the mine working areas and prevent subsidence from happening in the future. And this could include a variety of different channel options, anything from like a riprap channel to compacted soil with a clay liner, or even the concrete revetment blocks like a mat. But all maintenance will have to be done by private residents, since this is all done on private property. So we're currently working with the landowners to see what is it that will be best suited for their maintenance needs. And those are our next steps that I just spoke about. So wanted to thank everybody, especially the New Mexico AML team. We had every member of our staff out there doing construction observation for these phases of projects, and everybody did a great job. So thank you.